This is just so funny that y'all can't.
And I'm officially done with this app. I'm on here entirely too long. See you in 15 minutes.
See y'all in 15 minutes. That's me. Yeah. All right, let's. What are we doing? What are you like, Cindy? What up? Hi, how you doing? All right, we're still doing rules. Rules. We don't follow rules. We don't like rules. Might need my pencil. Not sure yet. All right. So what we're going to do is we're going to talk about there is a product and a quotient rule. This first part we'll just talk about the product, and then the next video we'll talk about the quotient rule. So the product rule is what's product? That's product you put in your hair. No. You multiply, right? So in other words, if we have two functions being multiplied, how do you know they're being multiplied? How do you know? How do you know? Because x squared times ln of x, you may not always see the dot. Okay, don't put an x. Oh Lord, no, that's like kindergarten stuff. So I need a way to understand a product rule, and then as I said, we'll learn about the quotient rule. So why do we even need a product rule for derivatives? Have you forgotten we're talking about derivatives? Forgot to mention that. We're talking about derivatives. So if I didn't need a product rule, I should be able to, in this case, it's easy to multiply x times x squared. When you multiply with the same bases, you do what to the exponents? Add. And so from here now, I could just simply use the shortcut where you bring the 3 down, pass it around, you're singing the song again, and 3 minus 1. So this is my x to the n, where the n comes down, which is 3, and n minus 1. So I'm hoping you're getting the power rule down. So the derivative of x cubed is 3x squared. Well, pretend you couldn't multiply these because you're going to have different functions that you can't multiply. So then why couldn't we just simply take the derivative of the first term? Remember, the derivative of x is 1 because that's 1x, and the derivative of x squared is 2x. And then we could just multiply them and we get the same answer. Didn't work, did it? So the problem is we need a way how to figure out to take an actual product. So a lot of times I will show boring proofs. Don't you just love proofs? I know you hate proofs. I show proofs for the math nerds out there. So if you're not a math nerd, just put your head down on your desk and take a nap, and we'll be right back. So basically, this definition of the limit looks familiar, kind of, sort of. Looks bigger, right? Because we have a product in here now. So we talked about f of x plus h minus f of x over h. But now we're going to put the second function in here. Okay, so the only way I can really tell you how we derived this product rule is with this proof. Now, in math books, I always find it funny because they go, it's obvious that you would plug this piece in here. I'm just going to tell you, okay? But if you notice, we added f of x times g of x plus h plus the negative, so added the negative or minus, the same thing. So we didn't change the problem. That piece is still 0. But the reason why, you're going to see why we did this, is now we can kind of manipulate this and say, well, let's factor out of these two blue boxes right here, them blue boxes right there, them rectangles. Let's factor out a g of x plus h, g of x plus h. So that leaves me left with f of x plus h minus f of x. All right, and so that now looks very familiar. I do the same thing in the red boxes, but I factor out an f of x, which actually gives me the limit definition now for the g of x. So I separate it, got to keep them separated. Y'all ain't even know that. Does anybody even know who Offspring is? They're a band. Google them. Separate. Got to keep them separated. Come out and play. I think that's the name of that song. All right, not my point. So I separated this into two fractions, and then I kind of pulled this g of x plus h out front. That is exactly the limit definition. I pulled the f of x out front. That is the exact limit definition, okay, for two different functions. So here, notice if I let h go to 0, that just becomes g of x. That is the limit definition. That is the actual definition of the derivative. You are like, why does she look over there? My phone. Somebody's texting me right now. Don't text me when I'm doing a video, okay? This is this f of x, and then this is the definition of the derivative. So what this shows me is this is actually the product rule. So in other words, the order doesn't matter because you're multiplying. I typically try to say this in words and write this down. I'm not really a country fan, but I think that's a George Strait song. Google that one too. So what this is saying is if you have two different functions and you want to take the derivative of them, and it's not possible to just multiply them. My example, we can multiply them, right? But let's say you can't. Then what you do, take the derivative of the first function, leave the second function alone, plus leave the first function alone, take the derivative of the second function. And that's how I kind of say it in words. Okay, so I understand I have two functions here, derivative of one, derivative of the other, leave those alone. So if we go back and we prove our silly example, because we could multiply this, x times x squared, and we got x cubed, and the derivative was 3x squared. Remember that? Well, let's see if the product rule works. So now there's something that I have seen students do, and I actually thought it was kind of cool in the past, is what they will do, they will take and they will label these, that is f of x, and that is g of x. And you might say, well, that's not that cool. Well, the reason why it's kind of cool is I will see them over here do this. F of x equals x. F prime, the derivative. Remember what the derivative is? 1x. Okay. See, I told you, stop messaging me. And then my g of x then is my second function, x squared. And then the derivative is what, 2x, because I brought the 2 down and subtracted 1. And you might say, okay, what's the big deal of that? Well, now you just plug everything in. So it's kind of cool when I see students do that. And so now I just plug everything in. Sorry that went away. I didn't want it to go away, but it's there. And now you just plug everything in. The derivative of the first function, 1. Leave the second one alone, x squared. Leave the first function alone, x. Derivative of the second, 2x, and then you combine like terms, and guess what? You get the same answer. And you might say, well, but why would you do all? You wouldn't if you could multiply them. The problem is when you get something like this, because now this is not functions you can actually multiply, right? Let's get blue, because I'm blue for you. So again, this might be one of these that over here on the side, you say your f of x is x squared. You say your g of x is ln of x. And now we have to take derivatives. La 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 la, 2x, and la 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 la. Oh, what was that? Didn't you just learn it? One, ah, ha, ha, ha. There you go. All right, and so then typically students will write the formula. Again, the order doesn't matter. You could say take the derivative 8 of the first one, leave the second one alone, leave the first one alone, take the derivative of the second one, and now from here I'm home free. I just go over here and find stuff. 2x, or g of x, that's ln of x. And then f of x, which is x squared, and then g prime of x, 1 over x. And then you just look to see if there's anything you can make look a little bit better. And the only thing really that I see, besides my terrible handwriting, is I could probably, remember this is x squared like over 1, so you could cancel one of those there. So in other words, that's x squared over x if you multiply them right, and that's how I end up with x. So this is a good, you need to have this formula, you know, it's a formula, right, a rule written down so you know how to actually work problems out using the product rule. And we will be back, ladies and gentlemen, with the quotient rule.